Good morning to all. I'm Mohan, Department of Mathematics. Uh, previously, the more classes we are discussed about the Cauchy's residue theorem and Cauchy's pole and simple pole. Even though we are a small part, we are already discussed about the residues at higher order poles. Here we have to see that the one more point, the residues at higher order poles, evaluating integrals and applications, because it is very important to the real life problems. So in this way, now the so many contents they are using in the evaluating integrals and applications with residues. So in this way, let me see that complex pole that already we discussed in the singularity with order greater than 1. Then the calculating residues using derivatives to find residues at higher order poles. Now we have to see that evaluating integrals. See, applying Cauchy's residue theorem for integrals with higher order poles. That is the very important. So here the calculating with apply Cauchy's residue theorem for integrals with higher order poles. Then it is applications where we using in this application to physics and the engineering problems using higher order residue theorem. See, in this residue theorem there is a 2 parametric, 3 parametric, they are used in the applications. Then the more applications of Cauchy's residue theorem. First one is evaluating improper integrals. So in these improper integrals, to solve integral that cannot be evaluating directly. So that is a very important thing, that the Cauchy's residue theorem, that improper integrals means we cannot be evaluated directly. So that will be, we have to derive into integrals. Then analyze poles and residues to study system stability and response. So solving electrical engineering problems, that is the very important point, that is the application of Cauchy's residue theorem to solving electrical and engineering problems. That means that analyze pole and residues to study system stability and response. So here that the solving electrical engineering problems and probability statistics and calculating that expected values. See here that calculate probabilities and expected values using residue theorem, that is the probability and statistics. See, probability, that the statistical officer that always using the probability and statistics, that is expected values using residue theory. And that the more important uses in this, that is the quantum mechanics calculations. See, in this quantum mechanics calculations determine the wave function and the particle behavior with the residue theory. So in these applications they are using the quantum mechanics calculations, that very important thing, that quantum mechanics, that is the very important in the mathematical tool. Then the finally conclusion, it is key that residue are essential for evaluating complex integrals, and the residue theorem provides a powerful method to calculate integrals. Then the residue calculations determining the higher order poles enable efficient evaluation of the complex contour integrals. And then practical applications, Cauchy's residue theorem has numerous applications in physics, engineering and mathematics, such as evaluating improper integrals. Then ongoing relevance. See that complex integration residue theorem, that the active areas of the research and continue to provide insight across disciplines, and that very important to the discipline. So here we are discussing the conclusion of the key that will be a residue theorem is a very calculating integrals, and that is the efficient evaluation of complex contour integrals, and that engineering field they are using and the research oriented. Thank you.